Isaac Newton, born on January 4, 1643, in Woolsthorpe, England, emerged from humble beginnings to become one of the most influential scientists ever. His early life was marked by adversity. Born prematurely and posthumously, he was a small child not expected to survive. Newton's education began at the King's School in Grantham, where his intellectual potential began to unfold. However, his mother pulled him out of school at age 12 to become a farmer, a profession he detested. Recognizing his disinterest in farming and his scholarly inclination, his uncle persuaded his mother to prepare him for the University of Cambridge, where Newton would later revolutionize science. His academic journey at Cambridge was transformative, laying the groundwork for his future discoveries. Despite the university's closure due to the plague in 1665, Newton viewed this period as the peak of his creativity, developing theories that would challenge the very foundations of science. The years 1665 to 1666, known as the Annus Mirabilis, or Year of Wonders, were pivotal for Newton. Forced to return to Woolsthorpe due to the plague, he engaged deeply with mathematical problems and the nature of motion and gravity. During this period, Newton formulated his theories of calculus, optics, and the law of gravitation. The isolation provided him with uninterrupted time to focus, leading to breakthroughs that formed the basis of modern physics. It was during these years that Newton experimented with prisms, dissecting sunlight into a spectrum of colors and laying the groundwork for his future work on light and color. Newton's three laws of motion, introduced in his seminal work Philosophiae Naturalis Principia Mathematica, revolutionized the understanding of physical phenomena. The first law, often known as the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. The second law provides a quantitative description of the force needed to produce acceleration on an object. The third law, the principle of action and reaction, underlines the mutual forces of action and reaction between two objects. These laws laid the foundation for classical mechanics, explaining everything from the motion of celestial bodies to the dynamics of everyday objects. Newton's universal law of gravitation was a monumental achievement, providing a mathematical explanation for the gravitational force that governs the motion of celestial bodies. He proposed that every mass exerts an attractive force on every other mass, with the force being directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law not only explained the elliptical orbits of planets but also unified terrestrial and celestial mechanics under one universal principle. It was a groundbreaking step forward in the understanding of the cosmos and remains a cornerstone of physics. Amidst his exploration of physics, Newton developed a new mathematical framework essential for his scientific theories: calculus. Although the invention of calculus was a contentious issue with German mathematician Gottfried Wilhelm Leibniz, Newton's method of fluxions, as he called it, was instrumental in describing the rate of change and providing the mathematical tools needed to support his laws of motion and gravitation. This development not only propelled his own work, but also provided a new language for future generations of scientists to describe the dynamics of complex systems. In his later years, Newton published Optics, where he detailed his experiments with light and color, introducing the world to the theory that white light is composed of colors of the spectrum. Newton's work in optics extended beyond the decomposition of light. He also studied the phenomenon of diffraction and theorized about the nature of light, proposing that light is composed of particles, a theory that would stand until the wave theory of light gained traction in the 19th century. However, Newton's particle theory would later find a place in the quantum mechanics of the 20th century, demonstrating his enduring influence on the field of physics. Newton's talents were not confined to the realm of science alone. In 1696, he was appointed Warden of the Royal Mint, a position he took very seriously. Newton applied his analytical skills to reform the currency and combat counterfeiting, a rampant problem at the time. He personally oversaw the recoining process, introduced measures to ensure the coins were harder to counterfeit, and even pursued counterfeiters relentlessly, ensuring they were brought to justice. His efforts helped to stabilize the British currency and showcased his diverse capabilities. In 1703, Isaac Newton was elected President of the Royal Society, an appointment that affirmed his status as one of the most distinguished scientists of his time. During his presidency, he used his position to further the cause of science, overseeing the publication of key scientific works, including his own. Newton's leadership helped elevate the Royal Society's status as a beacon of scientific inquiry, fostering an environment where knowledge could flourish. Newton's interests extended far beyond the physical sciences. He was deeply religious and spent a considerable amount of time studying the Bible, prophecy, and church history. He wrote extensively on Christian doctrine, albeit his views were often unorthodox, and he was particularly fascinated by biblical prophecy and the design of Solomon's temple. Newton's theological writings, which were published posthumously, reveal a man seeking to understand the universe not just through the lens of science but also through faith. Contrary to the image of the rational scientist, Newton was also deeply immersed in the world of alchemy. He conducted numerous experiments in search of the philosopher's stone, which was believed to turn base metals into gold and grant immortality. These alchemical pursuits, though often dismissed by historians, played a crucial role in developing his understanding of matter and may have indirectly contributed to his scientific discoveries. Isaac Newton was known for his complex personality. He was solitary by nature, prone to depression, and had few close friends. His relationships with other scientists were often strained due to intense rivalries, most notably with Robert Hooke and Gottfried Wilhelm Leibniz over the invention of calculus. Despite these conflicts, Newton's contributions to science and mathematics were unmatched, earning him a revered place in history. The story of Newton discovering gravity after being hit on the head by an apple is one of the most enduring myths about his life. While the tale is likely apocryphal, Newton did recount watching an apple fall from a tree, leading him to ponder the forces at work. This anecdote, whether fact or embellished, symbolizes Newton's curiosity and his revolutionary approach to understanding the natural world. Isaac Newton's legacy is immeasurable. His laws of motion and universal gravitation laid the groundwork for classical mechanics, while his calculus revolutionized mathematics. Newton's work has shaped the course of scientific inquiry for centuries, influencing countless fields and paving the way for future generations of scientists. His genius lies in his ability to see the world in a way no one had before, combining rigorous experimentation with mathematical precision. Newton's discoveries had profound implications beyond the realms of science and mathematics, influencing the philosophy of the Enlightenment. His mechanistic view of the universe contributed to the rise of rationalism and empiricism, shaping the intellectual landscape of the 18th century. Philosophers like Voltaire and Locke drew on Newton's work to argue for a universe governed by natural laws, accessible through reason and observation. Isaac Newton's contributions to science and mathematics have left an indelible mark on the world. His relentless pursuit of knowledge, combined with his extraordinary intellect, transformed our understanding of the universe. Newton's work continues to inspire scientists, scholars, and dreamers, reminding us of the power of curiosity and the endless possibilities of the human mind. As we explore the mysteries of the cosmos, we walk in the footsteps of this immortal genius, forever grateful for the paths he illuminated.